On this slide, I'm going to show you the flow of messages as they are being queued up into a queue service, and then they're being processed by the individual services that need those messages. And we'll draw a compare and contrast, again, messaging with network communication and messaging communication. So here in this cluster, you can see I have a lot of different things, and we'll just walk through it as I go through the demo. A client request comes in from the internet into your cluster, and where it first hits a load balancer. Now this is regular networking communication that's happening here, like an HTTP request is the most common thing that could be happening here. And the load balancer is then going to forward that HTTP request to one of the instances running our website service. In this case, it shows website number 1. Now, the website number 1 code, it's processing this client request that came in, and it needs to go and talk to service A, one of the instances of service A. Now, from what I'd shown you in the past, it would do a network communication, and it might have to use the DNS, and it might have to go through a reverse proxy in order to find service A. But in this example here, service A, I've created a queue service for it instead. And I'm now going to have website 1 queue a message up into the queue service. And that message is basically saying, service A, I need you to do some processing for me. Now, once that message has been queued up into the queue service, then that arrow goes back, right, because we've completed the queuing of that request. So now website 1 is going to periodically poll its own queue. This is a queue for the website 1 service that it will periodically poll, waiting for a reply to come back. I'll talk more about that a little bit closer to the end, but I'll just introduce the concept now, but I'll say more later. Website 1, of course, does not return back to the client and to the internet because it's still waiting for all this processing to complete. Now, we have this queue service A, and a message has been queued up to it, and I have 3 instances of this service A running over here. When those instances are idle, they periodically go up to the queue service to pull a message out. So let's say that instance 3 was the first one to go to the queue service and say, I'm ready to process a message. And of course, it's doing that because it's idle and not doing other work. So we get this great load balancing across these 3 instances by having them all go to the queue service to pull messages out. So now instance 3 goes and gets that message from the QA, and it starts doing some processing. Now, what if it needs to go and send something off to service B? Well, it can then queue up something into service B's queue. And in this case for service B, we have 2 instances, because maybe that's all we needed for scalability reasons. One of those instances also periodically go to QB and say, do you have a message? Do you have a message? Do you have a message? Well, let's say in this case that instance number 1 is the first one to go to QB now and says, I'm looking for a message. So QB hands off that message to instance number 1, and now instance 1 starts processing that message. Now, when it's done processing the message, it needs to send the result back into service A. So the way it will do that, though, is it will put it back into the queue. And now the result of that can actually be handled by any instance of service A. So it could be that instance 1 goes to the queue and pulls that out in order to process the result. You see, if you're using networking communication like I talked about in the previous section, then instance 3 of service A would have made the request to some instance of service B, and it would be waiting for the reply, and then service B would reply to that same instance. But maybe this instance is busy doing other things. By queuing the response up into QA, then some relatively idle instance of service A can go and process that response. And you could, in a way, say that this is treating the service instances more like cattle and less like pets. Right? When service instance 3 made the request to B, this became a pet in a way because the response from B had to go to this particular instance. But we would like to treat all the instances as a homogeneous set, and it doesn't matter which one does anything. And by using this queue, we get to effectively turn these pets into cattle, where now instance 1 can go and process the response instead of instance 3. The nice thing about that too is that if instance 3 just went down and crashed, now instance 1 can go and process the response. Whereas with networking communication, if instance 3 went down while it was waiting for the reply, then this would reply to somebody who doesn't exist anymore, and then we'd have to go back further to the left and start the retry process all over again. Right? And then we would have to process service A again, then process service B again, right? And it would hurt the overall latency or performance of the entire application running within this cluster. All right, so service A, instance 1, goes and pulls the message from the queue, and now it wants to send the reply back. Now we have a problem here. Because website number 1 was using networking communication, this website number 1 is effectively a pet, right? Not a piece of cattle. And so when this is done, it has to get the result somehow into website 1 because it is the instance that must reply to the client over the internet. So the way that I'm effectively turning these queuing of messages back into a specific instance that's going to get the response is I created a queue for each website instance. Whereas here I had a queue for all instances of A and one queue for all instances of B. Here I have a separate queue for each of the individual websites. So when service A is done with the results, it needs to go and tell website 1 instance, here's the result. So it's going to queue it to website number 1's specific queue. Now, also notice, and then website number 1, it's going to pull this queue, get it, and it's going to send the response back to the client, right? So that completes the entire flow throughout this system. But another thing I want to point out is, what if when service B was done, it didn't have to send it to service A? What if when service B was done, it could just simply put the result back into website number 1? Well, again, when you're using message queues, then service B, instance 1, could have immediately queued the response message into the website 1 queue. It didn't have to go back to QA. But if you're using the networking protocol, the networking communication, then it's always request reply. So you have client talks to server, server talks to server, and server talks to maybe another server, and then you have to flow all the way back, the exact same way you came in. But with queues, you don't have to. With queues, you can flow from website 1 to service A to service B, and then the response could go right back to website 1, and you can skip going through service A again. Again, this improves efficiency. It reduces network traffic in the cluster. Your customer gets a response faster, right? There's a lot of benefits to doing this. So that's what this node is over here, right? That request reply isn't required in this scenario. Service B instance 1 could post to the queue for website number 1, and it doesn't have to queue to QA, unless, of course, QA needed to do some post-processing after service A needed to do some post-processing after service B was done with its workload. But that depends on what your scenario is exactly. Okay, so now that service A queued it up to the queue for website number 1. Website number 1 periodically polls its queue, sees that there's a response, knows for which client request this is a response for, and so now the arrows rewind all the way back out, and the client has ultimately gotten a response here. Okay. I also have a note here at the bottom that all service A and service B instances could go down. They could all go down simultaneously. And when they come back up, recovery would simply be automatic because they would just start queuing or pulling things from the queues and continue processing again. Right? But notice that if website number 1 goes down, then the originator back here would have to start retry operations again. So again, it's this benefit of using message queues as opposed to doing networking communication.